video of the previous session and ask any questions if you have. Just to tell you some theoretical concept about the history of cryptocurrencies. This is the list of very early cryptographic digital currencies. All failed. All failed. DigiCash, Mondex, you know, the first one, DigiCash, in 1989. This was the first. All have some problems. One of the most problems was the security. The security, when I want to pay something digitally, it's very important. The security is very important. Another problem is double spending. What is double spending? I have some money. I want to buy something, okay? If I can spend my money at least 2 times, it will be called double spending. For the physical money, double spending is not possible because the physical money, when I want to buy something, I pay the money, and after that I receive the, okay, the money to be double spent for the physical money. But for digital money, it's important that there should be protocols, there should be some structures that prevent me from double spending. So if I want to talk about the online shopping, there's a historic part here. For many of us, online payments and online shopping today, it's a simple aspect. So it's very simple. Okay, we can simply buy everything internet and we can pay the money online. But in 1974, it wasn't possible. In 1974, in 1974, just 2 computers could be connected, and after that, IP invented, so some computers could be connected to each other, and in 1990, some protocols like HTTP or hypertext transfer protocol was invented. So many web but for the first sale in the world, we can call the Pizza Hut, okay, in 1994. It was the first online sale in the world. But what was the problem? The problem was online payments. In Pizza Hut, you can put physically, okay, and from that day, payments as online. But another problem, as you know, in 2008, bankrupted. Many of them feared about their money. How can I keep my money? How spend my money without using your ID? It's important that we use cryptography technique. Cryptography is communications theories. Suppose a message to one of you, for example, Ahmed. Consider this channel environment for the communication. This is our communication environment. But I want just Ahmed can be able to read my message, not others. Okay, cryptography is a technique. But I put my message like this, and there. Approach. So text for what? Or in cryptography, the plain text should be encrypted. I can read my message, so text. Okay. We will write very simple program and decrypt message. And some of you just can decrypt the message. Okay. Yeah. After encryption, sorry. Mechanism details in next sessions. Okay. It's just introduction. We have an introduction. So cryptography is the coin, every cryptocurrency. There are different approaches for cryptography. Some are symmetric cryptographies, in which both sides, sender and receiver, use the same key, but a stronger approach is asymmetric cryptography, which uses public and private keys. At least, I think, 2 or 3 weeks of cryptography approaches, especially RSA algorithm and the elliptical curve algorithm. Most of the cryptocurrencies, like Bitcoin, uses cryptography. And I will show you how to implement them in Python, both RSA and elliptical curve. This picture shows a history of the cryptography from ancient times and in the World War II 1920s, Enigma machine, and from 1976 till now, which we can use asymmetric cryptography. In this picture, you can see Alice. Alice wants to send a message to Bob. Her message is "Hello, Bob," and he encrypts the message using Bob's public key. And after encryption, you can see that "Hello, Bob" will be encrypted through a message 7AG7680191B02FN3. And Bob, after receiving the encrypted message using his private key, can encrypt the message. And as I said, in later sessions, I will talk in detail about asymmetric cryptography. And so let's go. Okay, as I said, in 1994, there was the first online sale, but the main problem was the paying online. Okay, and there are till now there are many digital currencies all failed. The first one, DigiCash, in 1989, and the last, Look, in 1999. Okay, the security and the double spending was the main problems. I think the reason that internet works today is like SSL, TLS from 1990s using HTTPS, for example. This is that online payments, we also need the cryptographic approach. Here, there's a riddle. How to transfer money peer-to-peer without any trusted central intermediary. In fact, how I can pay money to another one without using a central third party, for example, without any bank. In fact, the cryptocurrencies solution of this. Okay, and the first one who said that the blockchain is the solution was Satoshi Nakamoto. We don't know who is really Satoshi Nakamoto. It's a fake name, maybe a person, maybe a group of person, maybe a company, I don't know. But Satoshi Nakamoto, using some idea was invented before, especially Hashcash and BitGold, combining them and using different other approaches, invent a cryptocurrency which was called Bitcoin, the first cryptocurrency in the world. Okay, Satoshi Nakamoto wrote white paper. This is the abstract. Peer-to-peer payments to be sent directly from one party to another, provide part of the solution. Okay, here's what Do you know what is digital signature? Is this a digital signature? Each of you, I'm sure, has a signature like this. This is mine. Okay, can we say this is digital signature? Satoshi Nakamoto solved some problems using digital signature. Okay, the answer is no, this is not digital signature. So what is digital signature? Digital signature is, in fact, is a string, a hashed string. And digital signature is a hash string created using the private key. And for each message, it differs. It contains many digits, many alphabet. It's not readable. In fact, using digital signature proves that you accept something. Okay, and Satoshi Nakamoto used digital signature to prevent double spending. See here? Digital signature provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending. What is double spending? Double spending means that I can spend some money 2 times or more. As I said, for the physical money, it's not possible, but for a digital one, maybe it's possible. Each cryptocurrency should solve the problem of double spending, and Satoshi Nakamoto solves the problem using digital. Okay, Satoshi says, we propose a solution to the double spending problem using a peer-to-peer network. The network timestamps transactions. Timestamp transaction means that some transactions that uses timestamps on it by hashing them into an ongoing chain of hash-based proof of work. What is hashing? I should send you some videos about hashing very soon. In data structure, I think you got familiar with the hashing, but I will send you 2 short videos about hashing. Like cryptography, hashing plays a role in the cryptocurrencies. As you can see, some hashing algorithms like SHA-1 or SHA-256 will be used in cryptocurrencies like Bitcoin and Ethereum. So it's very important. Okay. Another thing, proof of work. What's proof of work? Proof of, in fact, is mining. I think you all here heard about the miners and mining. Okay. Proof of work, in fact, one of the approaches to do proof of work is mining. The idea was taken from the email servers. You know all what's spam? Huh? We all every day receive some spams. Some early solutions to prevent spams was that, okay, as a mail server, if you want to send an email by me, you should simply do some calculations, very simple calculation, just for example 1 second. I say, okay, 1 second is nothing. I want to send an email to Ali, okay, in the background, and I can't see, but in the my computer can do some computation, just 1 second, and after that my email will be sent to Ali. But I want to generate some spam, for example 10,000 spam email, so I should spend 10,000 seconds to send that emails, and it prevents some spammers. Okay, based on this idea, proof of work said you should do some calculations. If you want to add a block to a blockchain, you should calculate something, and later in the next sessions we will talk about proof of work in detail, and we will write a program to mine some blocks with some difficulty. Okay, let's go. Forming a record we changed without redoing the in fact, Satoshi says that the data on this network should be immutable. Nobody can delete or change the data. So I sent some money to another one. This transaction should be recorded without any changes in the blockchain. Nobody can change it. Okay? The longest chain not only serves as proof of the sequence of events witnessed, but proof that it came from the largest pool of CPU power. As long as a majority of CPU power is controlled by no cooperating to attack the network, they will generate the longest chain and outpace attackers. The network itself requires minimal structure, best effort basis, and nodes can leave and rejoin the network at will, accepting the longest proof of work chain as proof of what happened while they were gone. The abstract of the Satoshi Nakamoto paper, there are some important terms: peer-to-peer, digital signature, double spending, time-step transactions, proof of work, hashing, longest chain. I will talk about these concepts in detail in next sessions. Just to familiar you this an introduction. The main part will be started from next week. So if you can understand some of them, don't worry. Later in next sessions we will talk about them in detail. And what is a blockchain? What a blockchain is time-step append only log of blocks, something like this. Some blocks are appended to the list one by one and appended only. Nobody can delete a block, nobody can change a block. Okay, note that Satoshi didn't invent the blockchain. Satoshi invented Bitcoin. In fact, the notion of blockchain was previously invented by other people, but Satoshi use that concepts beside together and invent the Bitcoin. As the first exercise, find the longest running blockchain. Okay? Every cryptocurrency has an explorer. For example, in this address etherscan.io, you can find the Ethereum Explorer. As you can see here is the price of the Ethereum. I prepared this picture last week. This was the price of each Ethereum. This is the latest blocks. Each block has a number. So the length of the chain of the Ethereum is more than 13 million. Okay, more than 13 million. And here are the transactions. Or for the Bitcoin, here is the Bitcoin Explorer. The latest, the largest chain is more than 700,000. Okay. So between these two, Ethereum has a larger chain, but you should find the largest one. I just want to use searches and be familiar with different coins. It's not very as I said, each blockchain and every cryptocurrency chain has a list of blocks. Okay, in fact, it has a chain. This chain has a length. Can you find the longest running blockchain? There are many cryptocurrencies: Bitcoin, Ethereum, Monero, Shiba, and many others. You can simply find their explorer, see the height of the last block, and between them you can choose the longest one. Okay, and the last thing for the today is the history of the first transaction in Bitcoin. Bitcoin was invented in 2009. Okay, Bitcoin was invented in 2009 by Satoshi Nakamoto. But the first transaction was recorded in 2010. In 2010, as you can see, one person named Laszlo Hanix sent such an email. You can search and find the mailing list in the internet. Exactly, you can find his email in the forum of the Bitcoin. He says that I will pay 10,000 Bitcoins for a couple of pizzas, just for 2 pizzas. Okay, like maybe 2 large ones and blah blah blah. The day after, in May 21st in 2010, he sent another message. So nobody wants to buy me pizza? Is the Bitcoin amount I'm offering too low? And finally, The day after, he says that I just want to report that I successfully traded 10,000 bitcoins for pizza. And he put some images of that pizza in this address, and also in this upper address you can find his messages. Okay. In 2010, 10,000 bitcoins was $41. In fact, $20.50 for a pizza. But now 10,000 bitcoin are $470 million. If you want to calculate for a pizza, it's $235 million. Too much money. Okay, so the first transaction in Bitcoin was recorded in 2010. I will talk about the issues next week, but some topics that I will talk about them in this course is historical introduction. I will talk about cryptographic approaches in details, then Merkle iteration, proof of stake and proof of work, block propagation and difficulty adjustment, transactions in Bitcoins and Ethereum, Lightning and types of attacks, forks and side blockchains. These are the topics which will be covered in this course. I use these two books as the references of the materials of this course. You can simply find them into internet. Mastering Bitcoin and Inside Blockchain. Okay, I suggest you these two books from the net and read some parts that you think it's additionally I will use the material which was provided by the MIT University, can be found at YouTube. I will send the videos to you based on the concept which in each session I will talk about that. I will send some videos from MIT and also some videos from University of London for the blockchain courses. Okay. I will try to cover the theoretical concepts by programming in Python. So I think learning the course by those programming concepts will be much interesting. Okay. In the previous session, I also talked about these concepts. If you have any question, you can ask about cryptocurrencies, about the course, about the blockchain. I don't know. Nothing? Send what? Send the link of books. Search the title. Okay, I will send, but you can search the title of this book, Mastering Bitcoin, instead of two famous books. Okay, I will send the links to the Telegram group. Okay. No more question? Okay, thank you. See you next week. Goodbye.